Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 15, a synthesis of representations of equivalent ratio collections. Okay, classwork, exploratory challenge. At the end of this morning's news segment, the local television station highlighted area pets that needed to be adopted. The station posted a specific website on the screen for viewers to find more information on the pets shown and the adoption process. The station producer checked the website 2 hours after the end of the broadcast and saw that the website had 24 views. 1 hour after that, the website had 36 views. So 2 hours after, 1 hour after that would be 3 hours. And those are the key components to this question. All right, so first that's just the given information. And what's the question? Well, that's exercise 1. Create a table to determine how many views of the website probably had 1 hour after the end of the broadcast based on how many views it had 2 and 3 hours after the end of the broadcast. So they want us to use this given information to determine how many they thought they should have had after 1 hour, and then continue and predict how many views the website will have 4, 5, and 6 hours later. So I want to find 1 hour, 4, 5, 6. We already know 2 and 3. So I want a table that goes from 1 to 6, and I'm going to compare two different things. I'm comparing hours, and in those hours, how many times did people view their website? So hours will be on one side, and viewings or views will be on the other. All right, so I want to know what 1 is. And I already do know what 2 is, and I already know what 3 is. 2 hours after the broadcast saw 24 views, so this would be 24. 3 hours, or 1 hour after the 2, which is 3, the website had 36 views. And the questions wants us to do 4, 5, and 6 as well, so I need 4, I need 5, and I need 6. So this is the layout of what we're trying to find. We know X's or H's, and we know Y's or V's. We want to know what K is, or our constant of proportionality. Okay, so let's pretend I didn't say constant of proportionality here. I'm getting ahead of myself. Let's just call it a rate at this time. Okay, at what rate are they getting views per hour? Okay, so 1 hour, we don't know, but 2 hours was 24 and 3 hours was 36. If I take these givens and I make a ratio of y over x, okay, y divided by x, 24 divided by 2 is 12. 36 divided by 3 is 12. So I'm multiplying by a same value, 12, every time. 1 times 12 is then, therefore, 12. 4 times 12 is 48. 5 times 12, and 6 times 12. And there are the views that we would expect to see after hours 4, 5, and 6. And after the first hour, we saw 12 views. So we've answered the question. Okay, so exercise 2 now is asking, what is the constant number that we're going to call C that makes these ratios equivalent? Well, I've already done that. The ratios are 24 over 2, 36 over 3, 48 over 4, 60 over 5. The constant that makes them equivalent is 12. So I would say C equals 12. Now it says, using an equation, represent the relationship between the number of views V the website received and the number of hours H after this morning's news broadcast. So keep in mind that we have already used the equation K equals Y divided by X. What they're asking for is an equation that's rearranged, and if I want to solve for Y, which is what they're asking for, I would multiply both sides by X. And if I multiply this side by X, these X's cancel, and I'm left with Y equals, and it's K times X, or just simply KX. Then if I use symmetry to just move everything around, flip it around, then Y equals KX. So that's the equation I want to use right there. And so I will move this right here. That's the equation we are going to use. Y equals KX. But in this situation, it says number of views V. and the number of hours h. There are no y's and x's, so we're going to substitute in. So I had little x's and y's up here to represent which is which, and our y is our views, so my y is going to become v. My k, in this case, is my c, so that is 12. My constant of proportionality, or my ratio that makes, what number makes these ratios equivalent? The constant number, the constant of proportionality is what we're going to lead into here, is my 12. So I'm going to put a 12 there in place of k. And then x is hours, and that is going to be replaced with the letter h. So in terms of v and h, then I could say the number of views equals 12 times the number of hours that have passed. Okay, exercise 3 now says, use the table created in exercise 1 to identify sets of ordered pairs that can be graphed. So I want to look back at my table and I want to make these ordered pairs. Now keep in mind, an ordered pair is a parentheses around with a comma. So all my ordered pairs are going to look like that. So I want 1 comma 12 all the way up through 6. So my ordered pairs are 1 comma 12, 2 comma 24, 3 comma 36, 4 comma 48, 5 comma 60, and 6 comma 72. Number 4. Use the ordered pairs you created to depict the relationship between the hours and numbers of views on the coordinate plane. Label your axes and create a title for the graph. Okay, so let's create a title first. And we're talking about views and hours. So if I go back to my table here, we're talking about views and hours, and this is views per hour. So let's call it that. Views per hour. So there's the title of our graph. And remember the x's and the y's. X's is hours, so I'm going to put hours down here. So our x-axis, if you will, you're used to seeing this as the x-axis. This is going to be our h-axis. And over here is the number of views. And so this is going to be my v-axis instead of y. So these are x's and I'm sorry, these are h's and these are v's. So I'm using the form h, comma, v. So 6 hours, 12 views. Now I want to graph these points. I want to plot these points. And there's a reason we call this the origin. That's where every point location originates. And these are our coordinates in what we move. So it's kind of like a GPS. This tells us go 1 unit to the right, and this tells us to go 12 units up. Okay? But I want to use a unit of measurement that would fit well in this, and our largest number that we're going out to is 6. So if I go 1, 2, 3, 4, 5, 6 like this is all going to be crunched up right here. Okay, and I always should probably look and see what other questions are being asked that will be on the graph. So I'm going to go ahead and do that. And exercise 5 says to predict how many views the website will have after 12 hours. So I needed to know that, because now I know that I'm going to be going all the way out to 12 comma something. Okay, and that's what that last question's asking. So I better make sure I can fit 12 in here so my answer's in my graph. So if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 12 will not fit. So I am going to just go by ones. If I wasn't going to go by ones, I would have spread that out and made the unit of measurement 2 per square or something like that, 2 hours per square. But in this case, I'm only going to go up to 12, because if I double it, it won't be on the grid. So I need to know what's going to happen here. So then I'm going to plot my points, 1, and then I need to go up this column, but look what's going on here. We have 72, but then we're going to have a really big number here. So if I go up by 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, right here is just getting to here, but we need to double that. because we've doubled this. Okay, so I'm going to go by tens. 10, 20, 30. Actually, I have room to do this one, might as well. This is 40 views, 50. Okay, but then when I go to graph these, look at my views. They're in 12s. This is not in 12. So where's 12? Well, it's between 10 and 20. It's somewhere in here. So I don't like that unit of measurement either. So how about I just go by 12s and make it easier for the reader? So this would be 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, 156, and so on. So we're just going to go there for now. And now I'm going to graph these points. So the point 1 comma 12 means start at the origin, go to the right 1, go up to 12 on the axis V, and there's 1 comma 12. And then go over to 2 up to 24, 336, 448, 560, 672, over to 7 up to 84, over to 8 and up to 96, 9 and so on, and continue doing this. And then I will get my ruler out. Okay, and I'm going to draw a nice straight line. Anytime you draw a graph, you should always use a ruler for a straight line. Okay, do not just try to draw it freehand. It will never be as straight as it could be. Okay, so right about there. And if I draw a line up through here, okay, and keep going up to there. All right. Okay, so there's my straight line. So what that means is if all these points graph that line, are on that line, then my prediction should also be on that line. So there's the graph. So it says label your axes, and I did. Create a title for your graph, we did, and plot the points. Do the points you plotted lie on a line? And the answer to that is definitely yes, it is on a straight line. And my points are here, and really what I should be doing, I'm not going to take the time in the video to do this, but you should always label every point with the coordinate 1 comma 12, 2 comma 24, and so on. Okay, since this is a little tight and it's hard for me to write with this pen, I won't do that. Okay, and then now moving on to that last question, it says, predict how many views the website will have after 12 hours. Use at least 2 representations. Well, I can use the graph that I just had here, and if I look at, let's use yellow. If I start at 12, if I go over to 12, what I want to do is go straight up and find that value on my number line. It is right there. Let me use black. There is the value I'm looking for, prediction of 12 on the number line. And what does that mean? That means how many views are over here, and the answer is 144. Okay, so using the graph, I just confirmed that there are 144 views in 12 hours. Okay, it says use at least 2 representations, and there's examples. So let's do a tape diagram. Tape diagrams are pretty cool. So if I am going to have a square, what am I comparing, by the way? I'm comparing hours to views. And let's draw a line way out like that. And if this is 1 hour, this is 1 view, 2, and we want the hours and views to have the same number of squares. And there's my 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So here's our views. So what it says is after 12 hours, so here's 1 hour. 1 hour is 1 square. There's 12 squares, that's 12 hours. And if an hour we had 12 views, then every single one of these is 12. Okay, and so on. I'm not going to fill them all in. So in order to answer this question, okay, how many squares do we have? 12. What is each square worth? 12. And 12 times 12 equals 144 views. So that's the same way we got graphing. We could do a double number line, which is very similar, and we've already done a table. So there's many ways we can do this. I'm only going to do those 2 ways there. Okay, but if we went back to our table, and I knew that 6 gave me 72, I multiply 6 times 2 to get 12. So if I multiply 72 times 2, I get 144 that way. Okay, so there's many, many ways we can come up with our solution to that problem. Okay, here's exercise 6. This is a cooking problem. And it says, also on the news broadcast, a chef from a local Italian restaurant demonstrated how he makes fresh pasta daily for his restaurant. The recipe for his pasta is below. He uses 3 eggs beaten, 1 teaspoon salt, 2 cups all-purpose flour, 2 tablespoons water, and 2 tablespoons vegetable oil. Determine the ratio of the number of tablespoons of water to the number of eggs. So we want water to eggs. Well, our water is right here, and our eggs are right here. So water is 2 tablespoons to 3 eggs. So our ratio is 2 to 3. Now it says provide the information in the table below, provided the information in the table below. Complete the table to determine ordered pairs. Use the ordered pairs to graph the relationship of the number of tablespoons of water to the number of eggs. All right, so we have 2 to 3 here. 2 tablespoons of water, we just figured out that that is 3 eggs because that's 1 recipe. So now if he doubles the recipe, he knows he has a large crowd coming and it's Friday or something, he needs more or so forth, whatever, then he can multiply his batch or make additional amounts. So if he uses 4 tablespoons of water, if it's 2 to 3, I multiply 2 times 2 to get 4, so I multiply 3 times 2 to get 6. So these are going up by 2, 2, 4, 6, 8, 10, 12, and these are going up by 3, 3, 6, 9, 12, 15, and 18. The ordered pairs would then be 2, 3, 4, 6. And please you make sure you put parentheses. The most common mistake is not using parentheses. Okay, 8, 12 is not an ordered pair that you graph. 8, 12 is just a list of 2 numbers. It could be the beginning of a sequence. So you need to put parentheses around those to tell people that you want that graphed. 10, 15, and finally 12, 18. Okay, so now we're going to use those ordered pairs and graph the relationship. So remembering from the last problem, we want to have a title. Okay, and this is, we're talking about pasta. So it's a pasta recipe. So we could have said pasta recipe. We could have said eggs per water or something like that. But the bottom here is tablespoons water. I'm going to abbreviate because of the room. They didn't give us much room to write this. And then over here is eggs. Okay, number of eggs. Okay, so now we're going to plot these points. So we start at the origin and we need a unit of measurement. We're going up to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can tell I'm already more than halfway, so I don't have room to skip. So I'm just going to use unit measurements of 1. Number of eggs goes up to 18. I probably don't have much more than just doing that over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. I also could have gone by threes because that's how many eggs we're using. We could have gone 3, 6, 9, 12, but we have plenty of room to do it this way. And now I'm going to plot the points. 2 comma 3 means to go over to 2, up to 3, and put a dot. Then we go from 2 to 4, and then up to 6. And then 6 on up to 9. And then 8 up to 12. 10 up to 15. And then finally 12 comma 18 is all the way up here. I'm then going to go get my ruler. Line it up the best I can here, putting it on the origin on this end and rotating it so it'll go through those points. And with any rotation, if you aren't centered, there's adjustments after the rotation. Okay, right there looks pretty good. So I'm going to draw a line and then move my ruler. Okay, so there's our graph. All our points are on that line. Let me make them a little bit larger so you can see them. Right here, right here. These are all the possible multiples of tablespoons that we could use different amounts of eggs to get the same recipe, just larger quantities. Okay, so now it says, what would you have to do to the graph in order to find how many eggs would be needed if the recipe was larger and called for 16 tablespoons of water? Well, I'd have to go out here, and I'd have to go 13, 14, 15, 16, and then I'd have to extend this up, and that's where we're going to run into trouble, and that's what we would have to do. So if this was a larger, or if I use a different unit of measurement, I might have been able to fit this on here. But at this point, if I went up to 16 and I kept going up, then my answer is going to be somewhere where this line crosses, which would be here, and then I'd go over here and see what that value is. Okay. Now it says demonstrate on your graph. How many eggs would be needed if the recipe called for 16 tablespoons of water? And I kind of just did. And I apologize for not making that more frequent, and so this was not as steep, so it would be on the graph. Okay, but as you can see, it would be up here somewhere, but I can answer the question if I know my rate. So rate is y divided by x, so I know it's 3 divided by 2. So if I have 16 and I have 3 halves here, going the other way we divide. So 16, and call it 16 over 1, divided by 3 over 2 is equivalent to 16 over 1 times the reciprocal of 3 over 2, which is 2/3. And that is going to give me 32 divided by 3. 9 times 3 is 27. 10 times 3 is 30. So that'd be 10 times 3 is 30 with a remainder of 2. Okay. Is that what that question asked for? Oh, no, it says, yes, 16 tablespoons of water. So I'm going the wrong way here, so disregard that. I would start over, but we're already 24 minutes in, so let me just fix that instead of editing it. Okay, so we are going to move this 16 tablespoons of water over here. Okay, I apologize for that, but I will fix it. So it's 16 tablespoons of water, not 16 eggs. I did it backwards. And 16 times 3 halves is, the 2 reduces the 16 to 8. And 8 times 3 is 24 eggs. So that's where I'd be over here. 24 would be all the way up here and then over. Okay. Exercise 7. Determine how many tablespoons of water will be needed if the chef is making a large batch of pasta and the recipe increases to 36 eggs. Okay, so I'm going to go back and look at my table. And you see this 18 here? Well, if I'm going to double that to 36 eggs, I'm just going to answer it here instead of going back and forth and back and forth. If I want 36 eggs, that's what this next question is asking for. So I have a table here and I'm adding 36. Well, if I know that I multiply that by 2, then I can take this value, multiply it by 2, and that's how I can find how many tablespoons of water. So it's going to be 24 tablespoons of water. Okay, support your reasoning using at least one diagram you find applies best to the situation. Explain why that tool is best to use. Okay, so that's why I explained it that way. If we just use the table, we can find multiples to get from 18 to 36 very easily, and then do the same to the x that we knew, or the tablespoons of water. Okay, that is the end of lesson 15. Go to your problem set.